Good morning. This is Robert Moyeda with the National Weather Service in Miami, and this is the dry season 2021-22 outlook. And I first want to acknowledge our partners here at the South Florida Water Management District. We are here today to give the outlook, and I thank them once again, as we've done in the past, for their partnership and opening the doors for us here to do the outlook. For those of you who have been part of these outlooks before, we'll follow a similar format. So I will describe the outlook from the National Weather Service perspective for the dry season, and then we'll be joined by Akin Owosina. He's the Bureau Chief of Hydrology and Hydraulics here at the South Florida Water Management District, and he will give the perspective from the water and hydrology side. And also after both of the presentations, we'll have time to take any questions. You can ask them verbally if you're joining us via audio as well. And you can also type in a question on the chat, and we'll be able to see it right here on the podium. So with that, we'll go ahead and start here with the dry season outlook from the National Weather Service perspective. So I'll wait for my screen to begin. There we go. So again, there's my name and title. So just a quick recap of the rainy season, which ended on October 15th. We had a slow start. Really didn't start until almost at the end of May, maybe right at the beginning of June. So that set us behind schedule, if you will, and also caused spring drought conditions to linger until really late in June, much later than normal. Otherwise, as you'll see in some of the graphics here, that will show it was a pretty normal rainy season as far as what the rainfall values were. We did have a couple of tropical systems. We had Tropical Storm Elsa in July and Tropical Depression Fred in August. It did bring some heavy rainfall to the far southern portions of the peninsula and also in southwest Florida, but really didn't cause any widespread precipitation across the southern peninsula, and especially not into the central peninsula. So really, all in all, we didn't have what we would consider to be a really big rainmaker over the entire region. They were more, the heavy rain events that we did have were a bit more localized, and not just with the tropical systems, but also we had some upper level low pressure systems that moved from the east and gave us some episodes of locally heavy rainfall and flooding. Really not at all unusual for a typical wet season in South Florida. So really, when you look at the numbers, normal is probably the best way to describe it if you had to describe it in a very simple sense. You look at the individual stations, of course, there's some variability, not just in the rainfall amounts that we had during the rainy season, but also relative to the normal for that same time frame. So where we saw most of the above normal values were in southwest Florida, near the Gulf Coast, where you can see, for example, Marco Island had over 43 inches. Naples was over 38 inches, so they were a few inches above normal. On the other hand, we had some values that were below normal for the wet season, especially on the East Coast and really right near the coast. For example, Fort Lauderdale, Hollywood International Airport, not quite 29 inches. They were almost 10 inches below normal. So we saw some of that variability, and again, that's not uncommon. To see that type of variability during during the wet season. Now, where the above and below normal areas end up, of course, that can change from year to year, but again, this variability is pretty common. This is a graphical representation of the rainfall for the wet season. The areas in yellow were values of 30 to 40 inches. Those were probably fairly close to normal, maybe a couple of inches on either side of normal. Where you see there's some brown right along the East Coast. Those were areas that got less than 30 inches, and those areas were certainly below normal, which we saw briefly in the previous table. And then the values which reflect above normal are reflected in this graphic more by the green colors, the lighter green and the darker green in the interior, really covering most of Collier County and even getting up into a good part of the interior of South Florida. A few patches of above normal also, especially in interior Broward County, and even some patches down into Miami-Dade County, but again, those were more spotty in nature. So looking at it from an area-wide perspective, so these graphics are courtesy of South Florida Water Management District. So this encompasses the majority of the wet season, except for maybe the first couple of weeks of the wet season. If you look down at the bottom, it says, where you see district-wide 33.27, and then the value there, or that percentage value, 99%. So at the end of the day, we almost came up exactly at the normal amount of rainfall for the district. So again, emphasizing this a very normal wet season, especially when it comes to the actual numbers. Now, the way it broke down, again, it will kind of indicate or just emphasize that normality, if you will, except for May. The first graphic here, which is May, the browns and reds show or an indication that we had much below normal rainfall. So we started the season really dry. Didn't start to get into that rainy season pattern until right at the beginning of June. So once we got into June and July, we're starting to see more of the greens and yellows. Those are values that are closer to normal for those respective time frames. And then as we move on to August, September, and October, again, pretty much about the same. Again, not too far from normal on either side. Now, there is a bit of an exception if you look at October, just these last few weeks. Up in Central Florida, it's beginning to dry out some more up there, right in the northern portion of the area that we look at, basically, the South Florida Water Management District area. So that's an indication that, that usually the dry season pattern tends to begin a little bit earlier in the northern areas, and it eventually filters its way down to the south. All right, so let's go ahead now and take a look at the outlook for the dry season. Let's look forward now. Last week, NOAA released its winter outlook, so that forms the basis for this outlook here. We're not going to deviate from that overall winter outlook, but we are going to provide details in this local dry season outlook. So we start off with the temperature outlook. So this is the winter. This map shows the winter temperature outlook. So basically December, January, and February. And it is favoring above normal temperatures for really most of the country, the entire eastern U.S., and really the entire southern tier of the country as well. And that, of course, includes Florida. The probability there and the bottom there, and the legend shows a 50 to 60% chance of above normal temperatures during the winter period. And if you actually project this out for the remainder of the dry season, those probabilities remain the same. So we're basically at a 50 to 60% chance of above normal temperatures for the entirety of the dry season. Now, switching over to precipitation, the southern tier of the U.S., the outlook is for below normal precipitation or drier than normal, and you see some areas of above normal precipitation in the central U.S., Great Lakes, and also in the northwestern United States. So for here in Florida, those probabilities are 40 to 50% chance. And again, this holds through the remainder of the dry season. So I'm just showing you the map for the 3 months that encompass winter. But if I were to show you the other ones, it would look almost exactly the same. Just for the interest of time and for brevity, just to understand that this probability of 40 to 50% applies also to the remainder of the dry season here in Florida. So an outlook of below normal precipitation would make sense that our drought outlook would be pointing at the development of drought conditions. Now, it's normal that in a South Florida dry season, once we get towards the second half of the dry season, we at least get into some, maybe borderline drought conditions, or even getting into what we call a moderate drought, with the expectation of below normal precipitation. Right now, the outlook is that we could get into drought development maybe as early as January. It might be maybe a little bit earlier than normal. And then as we progress through the second half or into the second half of the dry season, depending on how we are rainfall-wise, it's possible that we could be getting into even, or that the drought conditions could worsen. But again, that's something that remains to be seen. But again, it makes sense that if we're calling for below normal precipitation at some point, the expectation at least is that we'll be getting into drought conditions, at least over parts of South Florida, especially in the second half of the dry season. So the seasonal forecast factors. So we're looking, what are some of the things that we look at when we're coming up with the outlook? We're looking at, of course, the ENSO, or the El Nino Southern Oscillation. This year we have a La Nina that's actually coming back, where some people refer to it as a double dip La Nina. So in other words, we had a La Nina last winter. It took a little bit of a break, and now it's coming back for this winter. So we'll talk a little bit about that here in the next few slides. We also look at long-term climate trends. So in other words, what have the trends been from in temperatures and precipitation over the last, let's say, 10 to 15 years. And then we also look at models, or we have models that actually do make projections for the next year or even longer. And these are dynamical as well as statistical models. Just brief primer on La Nina. We cover this every year. We showed the same exact slide last year when we were anticipating the onset of La Nina. La Nina is part of what we call ENSO, or ENSO stands for El Nino Southern Oscillation. It occurs, or the return interval is about every 3 to 7 years, but they can repeat from one year to the next, or this double dip that I referred to, and that's what we're expecting this year, or this season, with La Nina. These are naturally occurring phenomena. They result from their interactions between the ocean surface and the atmosphere with the tropical Pacific, and these in turn affect tropical rainfall patterns and winds, and they eventually feed back into the ocean temperatures and currents in the Pacific Ocean, and then they in turn cause, or lead to, I should say, changes in the weather patterns for a particular season, or maybe sometimes spanning a couple of seasons. But it's, so we look at the ocean temperatures in the tropical Pacific as our indicator of whether we're in La Nina, El Nino, or neutral. But that's not all. We need to see what we call coupling, or atmospheric coupling. In other words, we want to make sure that the conditions that are being, or the conditions that we're seeing in the sea surface temperatures in the Pacific are actually translating to the expected impacts, or the expected changes in those weather patterns that we typically see during each of these seasons or phases, whether it's La Nina or El Nino. So this goes back to 1950. So what we're seeing here, this is essentially this oscillation. As the name implies, El Nino Southern Oscillation. The orange colors there are the warm episodes, or El Nino phases, and the blues are the cold phase, or the La Nina phase. In other words, when temperatures were colder than normal in the tropical Pacific Ocean. So you see there's a lot of variability. Obviously, it changes from, most of the time it'll change from one year to the next. Or we can go from a neutral year, or we can go from La Nina to neutral, or sometimes we'll go from El Nino all the way to La Nina. Now, the one thing that's in play for this particular season coming up is we have a returning La Nina, or in other words, a second consecutive year of La Nina. So the circles denote previous multi-year La Nina events. So this is certainly not a rare thing. In fact, it's happened. It happened most recently in 2018, 2012, and also a couple of times in the 2000 decade. So this is not unusual. We've seen this happen several times. So this is the probabilistic, or in other words, we're kind of taking into account the different models that make projections of the sea surface temperatures in the Pacific Ocean. So the indication here is that what's the most likely phase that we'll be in. So if you look at the bars here for November, December, January, for example, then December, January, February, going on into the spring of 2022, we have a high likelihood of La Nina conditions continuing. In fact, it's as high as 87%, I believe, for the winter months, December, January, February. As usual, it diminishes some as you get into the spring months. But even then, for February, March, and April, we have over 60% chance of remaining in La Nina conditions. So the summary is La Nina conditions are expected through February and likely to persist at least through April. For those of you who like to get it more into the weeds when it comes to the individual models, it kind of resembles the familiar spaghetti plots that we see when we're tracking tropical systems out there. So these are individual models indicating what the sea surface temperatures in the Pacific Ocean related to normal. So the black line there in the middle is normal, and all the lines basically, or most of the lines basically being below or below the zero line means that we're expecting cooler than normal temperatures in the tropical Pacific Ocean. So the line this is the line here that just popped up here. That line is basically the threshold for La Nina conditions. So most of those lines dip below that 0.5 degree threshold. So again, that's the official indicator for La Nina conditions, is when the sea surface temperatures get below 0.5 degrees below normal. So La Nina helps to set the stage for the potential impacts that we could expect in any region regarding temperatures and precipitation. It's not a direct cause, but it helps set the stage. So this is the stage here. It's being set. So this is the typical pattern of temperature, precipitation in North America, as well as the jet stream, a typical jet stream pattern that we see during La Nina winters. And it's basically a northward displacement of the jet stream. So the jet stream is the thick blue line here. During the opposite phase, or El Nino, this jet stream could be located much farther south, maybe over the southern tier of the U.S., Gulf of Mexico, and Florida. During La Nina winters, it shifts to the north. And the jet stream location, more or less, not exactly, but more or less, can give you an idea of the sort of the dividing line between the colder air to the north and warmer air to the south. Again, it's not a perfect one-to-one relationship, but it's in a general sense, that's a good way to describe it. So the farther north the jet stream is, the farther north the jet stream is, more than likely it means that the colder air is going to stay farther to the north for longer periods of time, potentially. So you see the cold air here from Alaska, northern parts of Canada, extending into the northern U.S. plains. So that's, again, a typical pattern, but there can be changes to this pattern that could be shorter duration, and we'll talk about that as well. So again, I just described kind of what the northern or more northward displacement of the jet stream usually causes or leads to as far as temperature is concerned, and also the jet stream being farther north causes the winter storm tracks to also follow that jet stream, therefore being well to the north of Florida. So when the cold fronts that occasionally move into the peninsula, move into the state, they'll tend, they'll tend to have less moisture associated with them as they move down because of that northward position of the jet stream, and the storm tracks, again, tend to stay farther north. So the end result is a tendency towards less storminess and rainfall that we would see during a normal dry season. Thank you. And also, as I mentioned, the jet stream being farther north can sometimes also cause fewer or weaker fronts getting into Florida, which would translate to temperatures remaining above normal for longer periods of time. So again, it's important to mention here, La Nina helps to set the stage. It's not a direct cause of any particular weather event that we experience, or even the overall average conditions that we're indicating here. And again, in the ENSO relationship to the local weather is not a direct one-to-one relationship. There are other patterns that influence or could even dominate for periods of time. And we're going to talk about a few of these oscillations. These are more temporary or shorter duration oscillations that can influence weather patterns and shorter time scales across North America. So we talked about ENSO, and more specifically this season, La Nina. So now let's take a look at how that relates to precipitation and temperature, looking back at past events. So the reason why we can say, at least with some confidence, that La Nina sets the stage for above normal temperatures and below normal precipitation in Florida is because we've seen that in past cases. So these graphics show for 22 past or previous La Nina events, the trends in the temperatures across the United States. So, for example, here in Florida, there is a 40 to 50% frequency of warmer than normal conditions during past La Nina winters. In other words, a trend that's fairly well established. If we switch over, okay, I'm sorry, this is still for temperature. Now, the one thing I did was I looked, okay, what does it look like for the second year episodes? Just a subset of the overall La Nina events. Let's just look at the more recent ones that have been second year events. Well, it's more of a mixed signal, actually. We actually had some years, those are the years up there above the map there, in which we had a second year La Nina. And actually for Florida, especially for the southern half of Florida, we actually ended up, the average was for near normal temperatures. So kind of a mixed signal. In fact, we had some of those winters in which we had that second year La Nina, we had severe freezes in both 1985 and 2009 over parts of South Florida. But then on the other hand, the most recent second year La Nina was 2018. We had a very warm winter. In fact, it was one of the warmest winters on record. So we've seen it on both sides of the spectrum here. So, it adds a little bit, certainly adds some uncertainty. And again, there's uncertainties in every one of these outlooks when we're going so far out in time. Now let's switch over to precipitation. So we're looking here at the past, La Nina events, and then we're also taking into account what's occurred in the past 15 years. Here, the signal's a bit more defined towards below normal precipitation. So in other words, in past La Nina winters, there was a greater than 70% frequency of drier than normal conditions, and that actually matches the trends that we've seen over the last 15 years. And if we look at the subset, again, breaking it down into just these second year La Nina events, the last 5 that we've had, there's actually a strong dry signal. You see those red colors here. The red colors over the southern and central part of the Florida Peninsula indicate well below normal precipitation during the dry season during these second year La Nina events. And in fact, the 2008-2009 winter or dry season actually was the driest dry season on record for most of Southeast Florida, and that again was a second year La Nina event. less precipitation, less storminess. We talked about in a few slides ago. So we would expect less storminess, less precipitation. We're going to have less severe weather events. And that translates, one way to show that is showing what the frequency of tornado events in South Florida has been by different phases of ENSO. So in a strong El Nino pattern, that's when we tend to have the most active stormy winters with tornadoes. And then when we have La Nina patterns, even a weak La Nina, like this one may end up being, we have a much lower or fewer tornadoes on average across South Florida. So again, makes sense. Less precipitation, less storminess, less tornado events. Doesn't mean we're not going to get any or that we can't get any, but they're fewer in number. Okay, and then the last piece of the puzzle are models. So we look at the models as well. What are the models actually showing for the next several months? And I'm just going to show you just a really quick composite or an ensemble of all the models. And this is for temperature. And it shows, again, favoring above normal. So the reds and oranges are reflective of above normal temperatures. So much of the southern U.S. above normal, with probabilities of about 70 to 80% chance, again, from the model ensembles, and a calibrated probability of about 50 to 60% of above normal temperatures from the ensemble, again, of all the models. For precipitation, again, below normal. So the red colors here, below normal precipitation, with about a calibrated probability from the models of 40 to 50%. So we've been talking about probabilities. And the probabilities are a good way or a good reminder that it's not the only possible outcome here. Now, if we were saying there's a 100% chance, then obviously that leaves no room for other potential outcomes. But in outlooks like these, that never happens. We always have, it's usually somewhere around 40, 50, maybe 60%. So, so these maps and these values reflect the most likely outcome, where there's greater confidence in going one side or the other. But again, it's not the only outcome. So obviously, if we're forecasting, let's say, for example, a 50% chance of below normal precipitation, that means that there's a 50% chance that it's going to be something else, that it'll be either near normal or above normal. Now, those probabilities taken individually are lower than the probability of below normal precipitation, but again, we can't discount them because there still is a chance. Lower chances, but they're still there. And the reason we have to mention these in probabilistic terms is because there are other factors. There are other intraseasonal cycles. And the Arctic Oscillation, for example, the Pacific North American Oscillation, the Madden-Julian Oscillation, all these can dominate the pattern even during active La Nina phases, and they can modify or they can influence weather patterns for a shorter period of time. They can either enhance or suppress the expected effects of the particular ENSO phase we're in, or they can counteract them. So those are the tricky events and things that we have to always look out for. Just give you two recent examples of these during second-year La Ninas. We talked about previously talked about the warm 2017-2018 winter. That was a winter which, in addition to having La Nina, we had a positive phase of the North Atlantic Oscillation. So when we experience positive phases, where we're in a positive phase of the North Atlantic Oscillation, that tends to reinforce that northward location of the jet stream, thereby keeping Florida and really much of the country on the warm side, with definitely what we saw in 2017 and 2018 during the winter months. Now, on the other side, in the 2008-2009 winter, again, a second-year La Nina, we actually had a predominant negative phase of this North Atlantic Oscillation. So The negative phases of the North Atlantic Oscillation usually lead to the jet stream shifting farther to the south, which opens the door, so to speak, for these cold air masses coming from the Arctic and from northern North America to move southward and potentially get into Florida. So we had several of those events in 2008, 2009. We ended up on the cool side that winter. Again, same La Nina phase, slightly different temperatures because of these other intraseasonal phases and cycles that again can modify or can disrupt a typical signal that we would see during La Nina, El Nino, etc. So putting all this together, as we always do when we come up with the outlook, so this is the local outlook for South Florida for the dry season. Of course, above normal temperatures, below normal precipitation, and you see the ranges there. Those are probable ranges, don't hold me to them. I just want to at least give an idea based on some of the models, what kind of values we could be seeing, at least relative to normal. Below normal number of storms or below normal stormy episodes, if you will. Now, the one that we always have to explain a bit more is freeze. So for freeze, we're saying near normal, although we're calling for above normal temperatures. Well, we average about 1 to 2 freeze events per season in southern Florida, again, mainly over the interior parts. It doesn't mean that a near normal number of freezes means we're going to have a cold winter. We could have a very warm winter and just have 1 or 2 episodes where the pattern temporarily breaks or shifts, like what we talked about in the past slide, and we get these cold air intrusions. So we've seen that actually in a number of La Nina years where it's been warmer than normal, but we get these sporadic shots of cold air or these cold outbreaks that can lead to freezing temperatures. And lastly, for the drought and wildfire, above normal potential for drought development, at least moderate drought development, maybe more. We'll have to wait and see on that. And that, of course, also relates directly to the wildfire potential, which is, again, above normal, mainly during the second half of the year. So this is the same information, but with confidence levels attached. I have maybe a little higher confidence in the below normal precipitation. The signals, at least historically, are stronger. No guarantee, of course. And also that relates to storminess. And for above normal temperatures, there's at least a moderate level of confidence. And that also reflects down to the chances for at least a couple of freeze events, or at least a few nights of freezing temperatures, again, mainly over those favored interior areas that typically experience at least 1 or 2 freeze events per year. So again, just as I wrap up here, always a reminder, these outlooks are just what that term implies. It's really a general big picture view of a set of conditions that we expect but are not guaranteed to happen. So they're always associated with a large degree of uncertainty with regards to specifics. So in other words, if you're banking on this outlook, let's say you have a big event on, let's say, January 15th. Is it going to be below normal precipitation and above normal temperatures on that day? Who knows? It could be anything on that particular day. So again, these are average conditions over the course of an entire season and not necessarily representative of what we're going to experience every single day or even every single week. Again, we can see these week to week or even month to month variations from the normal. But again, bringing it all together for the season, these are the conditions that we're expecting. So in that sense, that's what's good for, useful for general planning and overall awareness, understanding that there still can be variations in a very local, in a shorter time frame. So when we're talking about the expectation of a below normal precipitation for that length of time, again, we look at drought conditions, wildfires. So that's probably the main potential impacts that we're going to be keeping a close eye on, and also maybe we end up just getting maybe, for example, a couple of cold outbreaks. They could still be severe enough to cause problems to our agriculture community, especially we have longer warm periods that could make crops more sensitive to cold outbreaks. And these are the favorite times. It doesn't mean that they always occur exactly during this time frame, but these are the typical time periods for these impacts. For example, rip currents in the fall, then once again, once we get closer to spring, freeze and cold temperatures during the winter months primarily. Our severe weather season normally starts to ramp up a bit towards the second half of the dry season, especially as we get towards the end of it. And that's also the case for wildfires and droughts. All right, so that concludes the National Weather Service part of the outlook. And now I will step aside and let Keen Owosina come in, and he's going to present the outlook from the South Florida Water Management District perspective. Thank you.
Thank you, Robert. All right. Good morning. My name is Akin Owosina. I'm Chief of Hydrology and Hydraulics at the South Florida Water Management District. And today I'll be talking to you about the current water conditions and the actions that the water management is taking as we transition into the dry season. First of all, for those who are not familiar with the district, the South Florida Water Management District is the oldest and largest of 5 water management districts in South Florida. We've been around providing services in the area of water resources since 1949. The district covers an area of about 18,000 square miles. We cover 16 counties, starting from the north in the area around Orlando, extending all the way to the Keys. Our mission is to safeguard the water resources and ecosystem within the 16-county region, to protect the communities from flooding, and to meet the region's water needs. Now, the tools we have for managing the water resources are mostly the primary flood control system, the Central and Southern Florida Water Project, or the CNSF project as it's often called. It comprises many miles, over 2,000 miles of canals and levees, several pump stations, control structures, but I'd like you to focus on the last 2 bullets. It includes significant amount of storage in Lake Okeechobee and the water conservation areas, which are going to be some of the areas I'll focus on as we talk about our plans for the dry season. So, Robert has talked about some of this already, but I thought it was important to reiterate and point out a few things about the rainfall, since water resources in Florida is guided essentially, we're a rainfall-driven system and is guided by the amount of rain we've received. On this chart, the height of the bar denotes the amount of rain that was observed in any one particular month. We're showing 2000 and 2021 here. And when you see the deeper blues, it means that that month saw more rainfall than the long-term average, and the height of the deeper blue is the excess. And when you see the red, it means that that month saw less rainfall than the long-term average, and the height of the red bar is the deficit. So if you look at the wet season, starting May of 2021, that we're just getting out of, as Robert mentioned, May started dry, and so you'd see there is a big red bar. But for the rest of the wet season, we're really near average, with only minor deviation from the long-term average observed in any of those months. Spatially, you've seen a couple of these maps also, but I'd like to emphasize 2 of them that show the spatial distribution of that rainfall that we showed. First of all, for the entire season, which is the map to your right, you're seeing about 99% of average. So as Robert mentioned, we got essentially a normal rainfall year. But even though it was near normal, or essentially normal, it's important to point out a couple of things. If you look to the upper part of the system, in the upper Kissimmee, that basin saw less than normal, only received 88% of what it typically gets in a wet season. The reason I highlight this will become apparent in a minute. Also, some areas along the East Coast also received less than normal. The area along the southeast coast, that basin, receiving 87% of the normal. So, With that in mind, I'm going to go through the system, starting from the north, and describe the current condition of the key water bodies or the storage within the system. Starting from the lakes in the upper Kissimmee Basin, and I'm going to use 3 of them as an example. The plots, the figures you're looking at essentially show hydrographs or the plot of the height of water level within the lakes. To help explain these, I'll take one of these and describe the components of each of the plots. The red line that you see that runs along each of these plots on the top is called the regulation schedule. It's developed by the Corps of Engineers, and essentially it represents one of the guiding tools for operating water level within the lake. When we're below the regulation schedule, we have the ability or the freedom to move to increase storage or to store more water to approach the regulation schedule. But when we're above the regulation schedule, we operate to lower the water level back to the regulation schedule. The shape of this schedule is really important and is an important hint to the strategy we're trying to operate. As we come out of the dry season and go into the wet season, we tend to lower the schedule or lower the lake levels so that we create space for the rainfall that is anticipated in the wet season. As we transition back towards the dry season, the schedule line goes up towards what we call the winter pool elevation, which is the high in the schedule. And we try to hold the lakes high so that we all have water in storage as we go through the dry months. What the lines in green and blue are showing are the actual water level in the lakes currently relative to the regulation schedule. And as you can see from the 2 images to your right, we have the water levels tracking closely to but below the current level. And if you remember, I mentioned that in the upper Kissimmee we had drier than normal conditions. And so for the rainy season, so you can see the evidence of this in the water levels being below the winter pool elevation. We're essentially starting in this part of the system a little bit drier than we would like to be coming into the dry season. The other plot, the one to your left, shows the Kissimmee, and that has a slightly different observation in water levels, and that's in part due to some active actions we're taking to release water from that system to flow into the restored part of the Kissimmee River. It's a conscious decision we're making, and at some point when the level gets to about 50, we have additional decisions to make on whether or not to reduce the releases to the Kissimmee River at that point. So the next set of graphics, I apologize, are very busy, but they're important to share, and I'm going to try to walk you through them so that it's easy enough to understand. But what you're looking at are a series of lines or traces that represent for a select number of years, the water level in Lake Okeechobee. Lake Okeechobee is the largest single lake within our system. It's often called the liquid heart of Florida. It's the one place where we often will get a sense for how we're going to fare water supply-wise based on what's happening within the lake. The magenta or the pinkish line that ends right inside that circle shows the water level for the current year. And I think I just advanced slide, I'll go back to it. Shows the water level for the current year. And for right now, it shows that we're roughly just below 16 feet. This is a good elevation to be in as we enter the dry season. It's high. If you compare it to several of the years that are also shown here, you'll see that it's higher than several years. It is lower than a few years, but it's really a good place to start the dry season from. This trace, which is even busier, represents several periods that Robert mentioned when we had the combination of things like the double dip, or where we had the La Nina type condition in back-to-back years. And I'm going to kind of pass this apart and take pieces at a time and help make the argument. Bottom line at the end of all of these slides is I'm going to reinforce to you that we're in a good place this year, and the outlook for the dry season as far as Lake Okeechobee is concerned is good. Starting with the 2000 to 2001 period, you would see that in the January of this year, current year, which is the dark black line, and the year 2000 trace are roughly about the same. But if you look in the period between June and October, which is the wet season, for this year, we recovered nicely because we had a normal year. In the year 2000, it was drier than normal year, and we started the dry season relatively lower. That's the solid gray line. That year, because our system has memory, and often you are not concerned only about the immediate dry season, but the wet season that follows. That year ended up with the district being in the water shortage area. It was a bad dry year for the system. We do not anticipate those conditions with the current year because we're starting much higher. Now, taking another period, the period between 2006 and 2008, again, we started January of 2006, roughly around the same place as we started January of 2021. But again, the wet season was relatively drier. The one thing I'd like to point out is, like in each of these years, as you approach the dry season, the net change in the lake is a constant reduction. And this is usually because things are dry, we're making releases, and the lake levels fall. Again, for this period, even though you saw significant drought, actually the lake got to the driest that it would get in the 2007 year. I don't anticipate that for the 2021 year because we're starting again a significantly higher level within the lake. And similarly for the period 2010 and 2011. So the key conclusion from looking at the historic data set is that looking at similar years where we have La Nina type conditions, we're starting in a much better situation this year than several of those years where we ended up in water shortage type conditions. So the outlook for right now is good as regards to Lake Okeechobee. Now, looking at the last couple of years that we've had, we're roughly in the same place as we were for the last year 2020, just about half a foot lower, and we stayed out of water shortage in 2020 into 2021, and so we hope that's what we'll have for the next year. But we don't rely just on the historic data and hope alone. We actually use some tools to try to do a forecast into potentially what we could see, starting with water levels as we have them today. So if you look on this chart, the solid magenta line shows the actual water levels within Lake Okeechobee as it's been observed this year. And then you see a series of lines, spaghetti plots that emanate from that one point in October. And that represents the summary results of many years of model simulations looking at historic rainfall that's been observed and seeing how the lake responds. The way to interpret this graphic, or what I'd like you to take away from this graphic, is that the area that's shaded in the purple shades there represents the 25th to 75th percentile chance of where the lake level will be. And that means that there's a 50% chance that will be within that window. And especially as you look at the end of the dry season, which is in the May, June area, you see that this keeps us away from the gray shaded area in the bottom, which is our water shortage band. If the water levels were projected to dip into that band before the start of the wet season, it means that the district will have to make a decision on whether or not to declare water shortage and restrict water use. But from our modeling, as well as from what we saw in the historic, with the starting point in the lake as what it is right now, all of the traces show a high likelihood that we will be out of the water shortage band throughout this dry season. Now, if you have the worst dry weather ever, there's a very low likelihood, but the chance still remains that we could get there, but it's highly unlikely based on everything, all the indicators that we're seeing. Robert mentioned La Nina, and he described it well enough that I'll just emphasize the middle bullet, that the way this typically affects us is that with regards to Lake Okeechobee, the net inflow into Lake Okeechobee is reduced when you have reduced rainfall. And that's what the chart your right shows. The blue lines represent La Nina type conditions. The zero line is net inflow essentially into Lake Okeechobee, and you see that these are negative as you go month to month, and explains why the lake level almost persistently falls through La Nina dry seasons. So with that in mind, we took a look at the model results and selected a subset of the years that represent La Nina conditions and plotted how the lake would respond, starting with the water levels today if we had rainfall similar to what we had in those dry seasons. Again, happy to show that through most of the dry season. We stay out of the water shortage line. There are a couple of traces. I think the blue one in there that represents the 1973 to 74 timeframe that takes us into the water shortage condition, but most of the other traces really have us in a comfortable area with regards to water level within the lake. So, with regards to the outlook, we feel good about where the lake is. I mentioned earlier that the Kissimmee is a little bit lower than where I would like it to be. The lake is right about where I would like to have it going into the dry season. How about the rest of the system? Some of our larger storages are the water conservation areas. There's the remnant Everglades south of Lake Okeechobee. And so what you're looking at on this graph, it's a little bit busy, but the key thing to focus on are the three charts to the side that are similar to the ones I shared for the Kissimmee system. The red lines represent the regulation schedule in the water conservation areas. And as you'll see, each of the water conservation areas is at or above the schedule, or hovering right where we'd like it to be at this point. So we're again entering the dry season with the water conservation areas being at the levels where essentially would like them to be. Robert shared this slide with you. This essentially tells you long-term what our expectations are for the system throughout this dry season. There is a higher likelihood that we'll have a dry season. That's what we expect for La Nina years, and our system is primed to be able to take us through a dry season. Now, we're not completely out of the hurricane season yet. We could still get some rain over the next several days, but if we get any rain, especially if it's up in the Kissimmee, it will set us up better by helping us fill some of those lakes. But if things get dry, we'll pay particular attention to the upper part of the system, which is starting a little bit lower, and we'll hopefully be able to manage Lake Okeechobee and water level in the conservation areas to navigate this dry season without having to be in a water shortage condition and without having environmental harm to those systems. We use additional tools other than the long-term projections to guide our day-to-day operations, and what I'm sharing here is a quantitative precipitation forecast that our meteorologists put together to help the water managers. It looks on a day-to-day basis over a week ahead and helps us make important day-to-day decisions on whether or not to operate some structures to let water out or to hold on to water. In addition to that, we make some key changes as we enter into this transitional period. And on this slide, I'm going to go ahead and summarize some of the activities we take as we transition into a dry season. One of the first things we do is there are some structures or pumps, especially the Ford pumps around Lake Okeechobee, that are pressed to use in dry season conditions. If the water levels drop significantly, we need to use those pumps, and to make sure that they're in good shape, we take the opportunity as we enter the dry season to test them and make sure that they're functioning well, and I'll be ready if we have to use them. We also take the opportunity as we start moving out of flood operations to maintain several of our structures or schedule or initiate maintenance activity on a number of our structures. And I've used the image to your right frequently. It shows a small crew on one of the structures doing routine maintenance work. One of the important things we do at this point is we switch our operation strategy. In the wet season, we're operating the system for flood control. We're trying to get water out of the system so that there is room to take rainfall and we can mitigate or reduce flood risk to the population we serve. As we transition to the dry season, we switch those operations into a water conserving strategy. With this strategy, we're holding our water levels higher. We're holding on to water we have so that we can have that water be available to the people through the dry season. We switch our canals from low range to a high range. By keeping it at a high range, it does a number of things. It holds on more water in the canals, which keeps more water in the groundwater, but it also importantly elevates the groundwater in this particular period of year to help battle or to help push back against the risk of saltwater intrusion. We also hold on to some water to hydrate our stormwater treatment areas. It's important for the stormwater treatment areas, which are man-made wetlands, to have a little bit of water in them at all times to keep the vegetation working and make sure that they do not dry out. So we hold water within parts of the system to be able to keep the stormwater treatment areas hydrated. As I mentioned earlier, we promote flows towards the coastal canal systems to maintain a higher groundwater level, to limit saltwater intrusion, and we're able to do this because with the reduced rainfall we anticipate, there is a reduced risk to flooding by holding the water table higher. We keep a tab on how things are changing throughout the system. We look at the dry season rain accumulations, because like a colleague of mine once described it, in Florida you don't really have a full dry season, you just have a drier than normal wet season and a slightly less rainfall in what you call your dry season period. So we keep an eye on that rainfall, and we try to make sure that operations are managed accordingly. But overall, we make sure that we're running the system, we're managing the system, so that the water we have in storage right now will last us through the dry season, all the way through May or June, or whenever the start of the next wet season is. This is my last slide. We'll be happy to take questions at this point, and I think Robert will join me for those questions.
Okay. Yes, thank you, Akin. We have time for some questions. You can say them using your microphone on your device, or you can also type them in, and we'll be able to read your questions here on the tablet on the podium. Any questions? All right. Second call for any questions. And again, we'll give time if somebody wants to type the question in. So we'll make sure that we get questions that way as well, and we can answer them. Okay, it's like a pretty quiet bunch so far. Usually we have a few questions, but that's okay. You can reach out to either of us afterwards if you want to. If you have any questions maybe that you think about afterwards, we'll be happy to answer those one-on-one if that's your preference. And also, I don't know. Oh, we have a question. Thank you. Let's see. How unusual is it for a double dip La Nina, and do we every? Okay. Oh, okay. Okay. So the question is, the way I understand it is, how unusual is it for a double dip La Nina, and do we ever get a double dip El Nino? Yeah, I showed that slide back closer to the beginning of my presentation. We've had several double dip La Ninas. In fact, the last one was just a few years ago, 2018. We had one in 2012. We had another one in 2009, and then we had a few more going back to the 1980s and 1970s. Okay, there you go. Thank you. Perfect. Now, as far as the double dip El Nino, we have had them, but not as many. In fact, let me bring up those circles there. Those are your double dip La Ninas. There are not as many double dip El Ninos, but I do see a few, especially in around 2004, 2005. We had one. We also had some in the early 1990s. We may have had one, actually, a very borderline one in 2019, 2020, but they're not as frequent, or actually they haven't occurred as often as the double dip La Nina. I don't know the reason for that. Maybe there's some literature that may indicate why that's the case, but I'm not really familiar with it. But yeah, there are certain. I think we've seen more of the repeat or double dip La Ninas versus its counterpart El Nino. All right. Any other questions? Okay, here we go. Here's another one. So, when considering whether we are in a drought or not, do groundwater levels play a role, or is it just rainfall? I'll let Akin answer that question.
Thank you. And yes, groundwater levels do play a role. And now often they're almost in direct response sometimes to rainfall. As you have drier and drier conditions and you have increased or continued water use, one of the things we track on an ongoing basis is the water level within multiple groundwater wells across the system. And one of the things you see during a drought is that a lot of those wells would fall to the low percentiles of what they typically are, or lower than they've been in historic record. So yes, the groundwater levels do play a role in determining whether or not we're in a drought. Surface water obviously does, but so does groundwater.
Do we have any other questions? Let's see. That looks like that might be it. So, okay, I guess we're up right up to noon here. But we still, if there's a question that you want to answer, you want to ask, please go right ahead. We'll be more than happy to stick around for an extra couple of minutes here. Otherwise, like I said before, you can reach us individually if you have any individual questions that you want to ask, as well as for any further information. And this information will be posted on the National Weather Service website, and I think also on the South Water Management District. They'll be putting it on their website as well. So here's one more question that just came in. Oh, okay, no, okay. Okay, it's a reminder. You can unmute yourself to ask a question. I think so that at the beginning you were muted by us, but you can unmute yourself to ask any questions. Okay, I think we'll wrap it up on this note. Again, you can reach us afterwards with any questions. I want to thank Akin once again for collaborating on this outlook. For everyone here at the South Florida Water Management District for your generosity, for your hosting us at this wonderful EOC facility here in West Palm Beach. And on behalf of the National Weather Service, I'd like to thank you once again. Thank you for participating, and have a safe weekend, and dry season. So take care.
Thank you.
Thank you.